Vapes are everywhere. They're ubiquitous. They're made to be disposable and cheap. Maybe too cheap. How do they manage to vaporize while costing cents to make? Is it more dangerous than just lung cancer? It's just about the most crude system you can imagine. To find out exactly what's going on, we'll need to see what vaping actually is, and explore the incredibly simple way this device works. Finally, we'll see what it takes to make it break. So what exactly is vaping? What makes it different from smoking? When something burns, it undergoes combustion. Combustion is just a chemical process where oxygen and another substance combine to release energy in an explosion. While vaporization is actually different. Vaporization is just heating up a substance so hot that it becomes light enough to float on the air. It's never burned or combusted. We vaporize things every day. Like when you boil water. So now we understand it's not a complicated thing. The reason these devices are so cheap is because they only have one job: to get hot. It's time to finally see what this looks like inside. Actually, it's pretty simple inside. This is the battery and the board that controls charging. We've all heard stories about these batteries. This is the sponge. It actually holds the liquid. And inside of there, they stuff this heating element which has wires and a wick. This here is what actually heats up. You'll see it's two bigger wires with either a small wire across, or in this case, a web of small wires. Before we see how this can go wrong, let's see how it works in the first place. To find out how hot it gets, we'll start with the equation for power. Each tiny segment contributes a little bit of heat according to this equation. When we double the current, the heat goes up by 4 times. When we double the resistance, the heat goes up by double also. To find the heat density, we'll need this equation for resistivity. Resistivity is just a measure of how much resistance a wire has per unit of length. So each tiny segment has a resistance of resistivity times length. Thinner wires tend to have higher resistivity. Now we use substitution to get rid of resistance in this equation. Finally, we divide by dl to find the heat density. This is the same as our original heat relation, except resistance has been replaced by resistivity. So where does this go wrong? We saw just now that doubling the current produces 4 times as much heat. So let's increase the current and see what happens. When it reaches its operating voltage, it starts vaporizing the liquid. At more than a volt above operating voltage, the cloth begins to clearly burn. And suddenly, the current drops because the wire itself has broken. Well, it looks like those thin wires can't handle the heat. What do you think it looks like when we suddenly increase the current? The heating element didn't burn up until just under 5 volts. So this is unlikely to cause an issue, because the battery is only 3.7 volts. I hope it goes without saying, you really shouldn't start smoking or pick up any unnecessary addictive habits. If you enjoyed this video, please like and subscribe. If you'd like to support us, please check out the link in the description to see our boards and electronics kits. Thank you for watching, and have a great day.